Hey, okay. So today we're going to do a more complex kinematics example than we have time to do in class, and hopefully this will help, and it will help you see how we go through problems and how we think about these things, what's going on. So we're going to follow, even though this is a much harder problem, the same basic steps that we use to solve all the other kinematics equations. We're going to draw ourselves a picture. We're going to write down our knowns and our unknowns. We're going to look at our equations and then try and figure out how to get what we need from what we have given the four kinematics equations. Okay, so that's how we're going to approach this. And bear in mind that just like any other kinematics problem solution, you could approach this one a different way as well. Okay, so if you can work out the problem, get the same answer with a different set of equations. Okay, here's the problem. A rocket is launched straight up with constant acceleration. 4 seconds after liftoff, a bolt falls off the side of the rocket. The bolt hits the ground 6 seconds after it detaches. What was the rocket's acceleration? It seems kind of impossible here because it doesn't seem like there's a lot of knowns, but actually it's solvable. So let's go through this. I have it all worked out. So first of all, I drew my picture like I always do. Start off here, and here's your rocket. It looks like a fish that's being caught because I can't draw with a darn, but there you go. So this is the situation at our initial time t is equal to 0. The rocket's taken off, it's launching. Here's our acceleration vector. Okay. Now, at t is equal to 4 seconds, it's reached the point where the bolt detaches. That's the bolt right there, okay? The rocket's got some velocity at this time. And note that the bolt also has this velocity at this time. If I can draw that vector there. There's my little velocity vector for the bolt and the rocket. It's the same at the instant that it detaches. Okay, but at the instant that it detaches, 4 seconds, after that it starts to fall, and then it hits the ground at t is equal to 10 seconds. Okay, so let's list our knowns. For the rocket, we know the following things. We know that it takes 4 seconds to reach whatever height that is, and I'll call it h. We know that its initial velocity is 0, and we know that its initial position is 0 because it's on the ground. It starts from rest. Okay, here's our knowns for the bolt. We know that once the bolt detaches from the rocket, that the acceleration is the acceleration due to gravity, minus 9.8 meters per second squared. We know that it takes 6 seconds for that bolt to fall to the ground because it detaches at 4 seconds and lands at 10. And we know that its final position is 0 because it hits the ground. We don't know its initial height. Speaking of we don't know. Here's the unknowns. We don't know that final height of the rocket at t is equal to 4 seconds. Okay? And it's also the same, that height, as the initial height of the bolt, but we don't know that value. I'll just call it h. We don't know the acceleration of our rocket. We don't know the final velocity of our rocket at t is equal to 4 seconds, but we do know that it's the same as that velocity of the bolt because they travel together until the bolt detaches. Okay? So we don't know what it is, but we do know that it's the same. Now, if we look at the equations for our rocket, we can write some things down. We can use this equation here, standard kinematics equations, y final equals y initial plus vt plus 1/2 at squared. Okay. Now let's plug in what we know and what we don't know, the variables we've chosen. So we know that the initial position and the initial velocity are 0, so I've plugged in for that. I've plugged in for my final position of the rocket, h. That's my for height. And then I don't know what the acceleration of the rocket is, but I do know the time that it took to get there. So I have h then is equal to 1/2 a rocket times 4 seconds squared. Now, I don't know the final velocity of that rocket, but I can write what it should be down in terms of the acceleration. So if I use Vf is equal to Vi plus At, one of our standard kinematics equations, I can write V final of the rocket is equal to the acceleration of the rocket times 4 seconds. Again, because the initial velocity of that rocket is equal to 0. So those are a couple of equations that I can write down for my rocket. Now let's look at our bolt. So yet again, I'm going to use that standard kinematics equation for my bolt. Y final equals y initial plus vt plus 1/2 at squared. Okay, I know the final position is 0. I'm calling that initial position h. Here's my initial velocity of the bolt when it just detaches from that rocket. My time is 6 seconds. And then my acceleration is acceleration due to gravity, and there's my time again in the 6 seconds. So this is my equation for my rocket here. Now, remember, from the rocket equations on the previous page, we had this. H is equal to 1/2 AR T squared, 4 seconds squared. VF of the rocket is acceleration of the rocket times 4 seconds. And also remember that at that time t is equal to 4 seconds, the bolt and the rocket are traveling together. So these velocities are going to be the same. So now I can plug in these equations here into my equation for my bolt. And side. This becomes my height here, and then my final velocity of my rocket I plug in for the initial velocity of my bolt because they're the same thing. So I plug this in here. Okay, so now I've got those things plugged in. Now notice something about my equation for my bolt. Okay, in my equation for my bolt, I only have one unknown, and that's the acceleration of my rocket. So that's what you want. You want the you want one equation, one unknown, okay? Or you want the same number of unknowns as equations here. So initially we started off with kind of 3 unknowns, but we had 3 equations, so we were good. And now we've reduced it to 1 equation and 1 unknown. So now it's just algebra. So what I'm going to do is I'm going to take everything that's not got the acceleration of the rocket in, I'm going to put it on the other side of the equation. So I'm going to take this here, and I'm going to subtract it from both sides. So that ends up canceling this out on this side, taking it over to this side with a 0. So 1/2 times 9.8 is 4.9, okay? And the sign changes because I moved it to the other side of the equation. So 4.9 times 6 seconds squared divided by, and now I've factored out 1/2 and the 4 seconds squared. These time terms here, I factor that out. And I put it on the bottom here and divided it out by both sides. Okay, so if you don't understand the algebra there, need a minute, go ahead and pause the video and make sure that you can get at this expression here. Make sure that you can arrive at this expression here. Okay? Pause if you need to do that. Now once I've done this expression, I can just plug and chug into my calculator and I arrive at the acceleration for my rocket, which is 5.51 meters per second squared, roughly, given the range. Okay.